In this presentation, we will discuss what is least element and what is greatest element. By the end of this lecture, learners would know what is a least element, what is a greatest element, important theorems on least and greatest elements, and how to find least and greatest elements from the Hasse diagram. So without any further delay, let's get started. Let's say we have a poset S, R where S is some arbitrary set and R is a partial order defined on set S. Okay, so we are considering some poset S, R where S is some arbitrary set and R is relation, which is a partial order relation defined on set S. Okay, now let us consider the definition of least element or minimum element. Okay, an element X belong to S is called the least element or minimum element of S if for all Y belong to S, X is related to Y. Let us suppose that there is some element X belong to S. Okay, if this element is a least element, then for all Y belong to S, X must be related to Y. This element must be related to every other element of S. Okay, then we can consider this element X as the least element. Okay, please note that least element is unique if it exists. It must be well noted that least element is unique if it exists. This simply means that there cannot be more than one least element possible for a particular partial order. Okay, now let's consider the definition of greatest element or maximum element. An element X belong to S is called the greatest element of S if for all Y belong to S, Y is related to X. Just opposite of what we have seen in least element, right? Here we have X related to Y and here we have Y related to X. Okay, so we are considering every element of S. Okay, and here X is called the greatest element of S if for all Y belong to S, Y is related to X. That means every element must be related to X if we consider X as the greatest element. Okay, please note that greatest element is unique if it exists. Again, least element and greatest element both must be unique. Now here is theorem 1. There is exactly one greatest element of a poset if such an element exists. Okay, we have seen that there is exactly one greatest element and one least element. So this theorem states that there is exactly one greatest element of a poset if such an element exists. Now let's just try to prove this theorem. Let's say that G and X are the greatest elements of set S. Let us suppose that G and X are the greatest elements of set S. I am considering two different greatest elements, and eventually what I do at the end, I'll just make both of them equal so that there could be only one greatest element possible. These two elements belong to set S and S, R is a poset. That's what I am considering. Okay, by the definition of greatest element, G is the greatest element of S if for all Y belong to S, Y is related to G, or for all Y belong to S, Y, G must belong to R. This is according to the definition of greatest element, right? For all Y belong to S, Y, G must belong to R. Because I'm considering that G is the greatest element, that's why this is possible. Also, X is an element of S. Here we are saying that for every Y belong to S, Y, G must belong to R. We know that X is also an element of S. Therefore, X, G must belong to R as well, right? Please note that X is also the greatest element of S, right? So we can say by the definition of greatest element, X is the greatest element of S if for all Y belong to S, Y is related to X, or Y, X must belong to R, right? Also, G is an element in set S, therefore G, X must also belong to R. Same reasoning, right? Here we have obtained X, G belongs to R, and here we have obtained G, X belong to R, because we are saying that Y, X belong to R for all Y belong to S. It must also be well noted that G is an element in set S, therefore G, X must belong to R, right? We know that X, G belongs to R and G, X belongs to R, therefore G must be equal to X. This is according to antisymmetric property, right? We know that R is antisymmetric because R is a partial order, right? Therefore G must be equal to X. That's what we have obtained, right? This means if a poset has more than one greatest element, then they are identical, right? If there are more than one greatest elements, then they are actually identical. This simply means there is exactly one greatest element possible in a poset. Now let's consider theorem 2. There is exactly one least element of a poset if such an element exists. Okay. Now here is the proof of this theorem. Let's say that L and X are the least elements of set S. I am considering S, R is a poset. L and X are the least elements. By the definition of least element, L is the least element of S if for all Y belong to S, L is related to Y or L, Y belongs to R. Right? This is according to the definition of least element. Least element must be related to every other element. Right? We know that we are considering every element of S. And we also know that X is an element of S, therefore L, X must belong to R, right? Also, it is important to note that X is also the least element of S. So by the definition of least element, X is the least element of S if for all Y belong to S, X is related to Y, or for all Y belong to S, X, Y belong to R, right? We can replace this Y by L because L is an element in set S, right? This is the result so obtained. X, L belongs to R. We know that L, X belong to R and X, L belong to R. Therefore, L must be equal to X because R is antisymmetric, right? This means if a poset has more than one least element, then they are identical. Therefore, there is exactly one least element possible in a poset. Okay, so the conclusion is simple. There is exactly one least element possible and there is exactly one greatest element possible in a poset. There cannot be more than one least element and one greatest element. Okay. Now here is one example. Determine whether the posets represented by the following Hess diagrams have a greatest and a least element. Okay, so we have to determine whether the posets represented by the following Hess diagrams have a greatest element and a least element. Let's consider this figure A. Here you can see in this figure, least element is A, but there is no greatest element. Why A is the least element? Because A is related to every other element, right? Also, you can see that there is no greatest element in this Hess diagram. Because if we consider C as the greatest element, then every element must be related to C. But D is not related to C and E is not related to C. So we cannot say that C is the greatest element. Apart from this, if we consider D as the greatest element, then every other element must be related to D. But C is not related to D and E is not related to D. So it is clear that D is not the greatest element. Again, if we consider element E as the greatest element, then every other element must be related to E. But C is not related to E and D is not related to E. So again it is clear that E is not the greatest element. So there is no greatest element in the partial order represented by this Hess diagram. So it is clear that the least element is A and there is no greatest element in this Hess diagram. Okay. Now let's consider figure B. In figure B, you can see that there is no least element and no greatest element, right? Because here if we consider A as the least element, then this element must be related to every other element, but A is not related to B, right? Similarly, B is also not the least element. Also, D is not the greatest element because E is not related to D. And E is also not the greatest element because D is not related to E. So it is clear that there is no least element and no greatest element in this figure, right? Now let's consider figure C. Here in this figure, least element is A and greatest element is D. It is quite clear, right? Here you can see the bottommost element is A and this element is related to every other element. Therefore, this element is a least element, right? D is the greatest element because every other element is related to D, right? In figure D, you can see that A is the least element and F is the greatest element. A is the least element because A is related to every other element. You can check this. While F is the greatest element because every element is related to F. Therefore, least element is A and greatest element is F. In figure E, you can see that A is the least element but there is no greatest element, right? If we say that E is the greatest element, then every element must be related to E. But D is not related to E, right? Also, D is not the greatest element because E is not related to D. Therefore, least element is A and there is no greatest element in this Hess diagram. Also, in figure F, there is no least element and there is no greatest element, right? It is quite clear. There is no least element and there is no greatest element. Okay? I hope it is clear to you that how to find the least element and the greatest element from the Hess diagram, right? Now let's move on to example 2. Let's consider this example. Find the greatest element and the least element of Poset, this particular Poset. Here you can see relation is divides relation, right? Let's first try to draw the Hess diagram from this Poset, and then it would be easier for us to find the greatest element and the least element of this particular Poset, okay? Let's first draw the Hess diagram. Here you can see first element is 2. And let me tell you, I will place this element in the bottommost place because this element is not divisible by any other element in this set. Therefore, I can place this element at the bottommost place, right? After this, next element is 4 and 4 is divisible by 2. Therefore, I can place 4 above 2. And also you can see that 6 is also divisible by 2, but 6 is not divisible by 4, right? Therefore, I can place 4 and 6 at the same level, and then I can draw an edge between 2 and 4 and 2 and 6, right? After this, we have element 9. 9 is not divisible by 4 and 6. Also, it is not divisible by 2. Therefore, we can place 9 in the same level as 4 and 6. After this, we have element 12. 12 is divisible by 4 and 12 is also divisible by 6. Therefore, we can place 12 above 4 and we can draw an edge between 4 and 12 and 6 and 12. Next element is 18. 18 is divisible by 9 and top elements are 12, 6 and 9, right? 18 is divisible by 9 and it is also divisible by 6, but it is not divisible by 12. Therefore, we can place 18 above 9 and we can draw an edge between 6 and 18 and 9 and 18, right? After this, the next element is 27. 27 is divisible by 9. It is not divisible by 18 and it is not divisible by 12. Therefore, we can place 27 over here and we can draw an edge between 9 and 27. After this, we have element 36. Top elements are 12, 18 and 27. 36 is divisible by 18. Therefore, we can place 36 above 18. And 36 is also divisible by 12. Therefore, we can draw an edge between 12 and 36 and 18 and 36. Please note that 27 does not divide 36. Okay. Now, the next element is 48. 48 is divisible by 12. Therefore, we can place an edge between 12 and 48, right? 48 is not divisible by 36. Neither it is divisible by 27. Right? So we cannot place an edge between 36 and 48 and 27 and 48, right? After this, the next element is 60 and 60 is divisible by 12, only 12. Therefore, we can place an edge between 60 and 12. Last element is 72 and 72 is divisible by 36. Therefore, we can place an edge between 36 and 72. So this is our Hess diagram, right? Now, we want to find the greatest element and the least element of this particular Poset. And we can find this with the help of this Hess diagram, right? Here you can see there is no least element and no greatest element in this particular Poset, right? Why is that so? If we consider 2 as the least element, then 2 must be related to every other element. But 2 is not related to 9. Therefore, 2 is not the least element. Also, 9 is not the least element because 9 is not related to every other element. In similar way, 48 cannot be the greatest element because 9 is not related to 48. Also, 72 cannot be the greatest element because 48 is not related to 72. Also, 60 cannot be considered as the greatest element because 48 is not related to 60 and 72 is also not related to 60. 27 is also not the greatest element because these elements are not related to 27. So it is clear that there is no greatest element and no least element in this Hess diagram. Okay. Therefore, it is clear that there is no greatest element and no least element in this Poset. Fine. Okay friends, this is it for now. Thank you for watching this presentation.